and welcome to the Developer's Guide to HCP Vault. Today we are going to be talking about rotating and dynamic secrets in yet another episode of A Developer's Perspective. I'm Rosemary, this is Michael. If you have not tuned in to these episodes before, hello, welcome.
Welcome
back. Appreciate you joining us. Welcome back. Yeah, welcome back if you're here again. It is our Monday stream, so it's a little bit quieter, a little bit slower, but we do want to hear from you if you have questions or comments. We do get some questions or comments. Sometimes we answer them live. Sometimes we don't. If we don't answer your question live, it's not because we don't see it. It's because it doesn't always come in a timely manner to our platform. So we may or may not see them immediately, but you will probably be able to find us responding to them later. So do ask a question if you're reviewing the replay and you're not sure what we're doing or you need clarification. This series is not the same as getting into Vault. We have a series for getting into Vault already, and that's for operators. I'm putting the link on the screen. It's going to be hashi.co/getting-into-vault. So if you are an operator who is trying to learn Vault, that is going to be the series for you. This is going to be focused mostly on developers. And that's because we get a lot of questions about development teams needing to adopt Vault in an organization. They need to do secrets management in their applications, and they're not really sure of the patterns that they should be considering or any of the problems that they might run into as they do it. So if you are an operator and you're responsible for writing documentation or enabling development teams to adopt Vault, or you're a developer tuning in, this is going to be the series for you. It is a limited run. I think we have 2 more episodes. Yeah, 2 more episodes.
Yes, I think this one and then next week.
Yeah, so this one and next week. And so it's going to be a little bit more limited than our usual Getting Into series, but the idea is this way. If you're a developer, you can go through for the next, couple, 5 at least different 5 series episodes worth of patterns that you should be aware of. If you missed any of our previous episodes, this is a very long intro. I'm sorry, Mike.
Yeah, I think last week we said we were going to work on getting a short link for that. We still need to do that.
I still have to get the short link. There's a playlist on YouTube. I will get the short link somehow.
Yes. Go to our YouTube. Yeah. There is a whole playlist for all of these if you missed any.
Exactly. And so definitely check them out if you missed any of them. We started with static secrets. So how do you get a secret out of Vault's key value secrets engine? And then we moved to secrets injection. So how do you make sure that your application can handle the injection of those secrets, right? It's not just as simple as read it from the Vault API, right? You have to be able to include retries and handling within the application. And then we talked about secret sync last week, which is a pattern that has to do with, in case you can't refactor your application and you are using a third-party secrets manager or some other service that's storing the secrets, is there a way you can synchronize between Vault still being your source of truth and a third-party service somewhere? We showed AWS Secrets Manager and GitHub Actions last week. And today we're going to be talking about rotating and dynamic secrets, because that's a whole other problem entirely, right? Because key value static secrets, when we were talking about them, we went into the Vault console and rotated it ourselves, right? But how do you handle automatically rotating secrets? How do you handle secrets that are issued dynamically, like on demand? There is a difference between rotating and dynamic, which we should probably talk about. But yeah, definitely keep that in mind. Anyway, as a reminder, if you are participating in chat, please follow our community guidelines. Be welcoming, be respectful, and be professional. We would love to hear from you, and we want to keep it a professional space for others to ask questions as well. Okay, I'm done with the introduction. That was very long.
Hey, great job. Great job. It's a Monday morning. I got some tea in my little coffee mug here.
Yeah, I omitted the tea this week. I have just water. I
have water.
Yeah, I have my coffee already.
I've been drinking a lot of tea recently.
Yeah. Wow. Oh, okay. All right. That's a new one.
I don't know.
Okay.
Yeah.
All right. Okay. Speaking of tea, we should probably spill the tea on rotating and dynamic credentials. That was a terrible transition, but
I loved it.
Thank you. Yeah. So what's the difference between a rotating credential versus a dynamic credential?
Yeah, and I think there's a third term that people also hear, like just-in-time credentials as well. And I think that kind of fits into dynamic credentials as well. So first, I'll start with those just-in-time or dynamic credentials. So we typically see those, or I typically see those in applications that need credentials just in time for something, right? So it could be a CI/CD platform or CI/CD runner. You're deploying your application to either AWS or your pipeline or something needs credentials for a very short limited period. And so you could leverage Vault's dynamic secrets engines to generate those short-lived credentials that again, you just need just in time access. So your pipeline says I need to talk to AWS, and then Vault can generate a 30-minute AWS credential. Same thing for Azure or GCP there. And then rotating credentials, that's something that we can store into Vault, and we might be able to set a specific auto rotation period as well there. So maybe not just in time, but something that rotates every 90 days or something like that.
Mm-hmm. And how do leases play into this? Because if you're a developer and you're looking at Vault or you're exploring Vault, you might find that some secrets engines have something called leases. So what does Vault's leasing system have to do with dynamic credentials or even just-in-time credentials?
Yeah, and that's a great question. I think for developers, when they first get started with Vault, they kind of treat it like a lot of other systems that might exist out, not necessarily secret systems, but just kind of API systems in general, where you say, hey, I have this API key to talk to this third-party system, and then that key necessarily could live forever, and then I can just continue to use that key over and over again. Vault takes a little bit of a different approach, and I think we talked about some of that when we went through authenticating in the KV secrets engine, and I think our first stream there. But users or applications exchange their identity for a specific Vault token, which doesn't last forever. So that's something that you'll see a lot in Vault and something for developers to be aware of. You authenticate into Vault and you get a Vault token that has a specific time to live to it. So you need to be aware of your that life cycle for authentication. Now, secrets also kind of play into that life cycle as well, especially generating dynamic or short-lived credentials, just-in-time credentials. When you generate a credential and you say, hey, this thing's going to have a 8-hour time to live, and then you can set like a default time to live of 30 minutes. So that means every 30 minutes you have to renew that token. And so that's where that lease comes in. So you ask Vault for a credential, Vault gives you back the credential, but it also gives you back a lease ID. And so we have to renew that lease ID before that default TTL expires. That way we can continue to use our credential. And then once you hit that max TTL, that max time to live, then we can request an entirely new set of credentials there, which is something that I think we'll go into later today when we get to the hands-on portion there.
Yeah, and it is worth pointing out that people do get confused. They're like, "Oh, Vault will remind me that this secret is expiring." No, you have to be very proactive in your application about acknowledging when that lease expires, right? So the best way to put this in this analogy, that it took a while for me to fully understand how this affects your application behavior, but effectively what your application is doing is asking, can I have these credentials for a certain period of time? And Vault will ask, not ask, but will ask, okay, here, I'll give you these credentials, but it's up to you to tell me when you want to renew, or if you need to get a new one because it's past the point in which you're allowed to renew, right? So it's almost like you leasing an item, right, or renting an item, and you have a contract, right? But no one is going to remind you that you have to renew the contract. So you just have to remember that you have to go and call back to whatever service provider you're using and say, I'm going to renew this contract for this year, and you do it every year until they tell you, okay, this is the, we leased this out to you for 10 years. That's the maximum. Now it's expired, right? So now we have to renegotiate terms. And so that's kind of how a Vault credential works with respect to a lease. It is up to your application to be proactive about this. Vault is not going to remind you that it's going to be expiring. Sort of like
Right.
you and your certificates and things like that too, right?
Right. But I think we saw in our second stream when we were talking about integration patterns. So there was that native integration, so you can refactor your application to talk to Vault directly. In that case, yes, you do have to be aware as a developer. You have to be aware that, hey, my authentication token could expire. I might have to generate a new one. My dynamic database credentials could expire. I have to keep that in mind and watch those as well. But we also have a lot of other integrations that kind of do that for you. So as a developer, if you don't really want to worry about that whole auth lifecycle or secret lifecycle, you can use Vault Agent as well as Vault Proxy, kind of all of the things that we went back in episode 2 and talked about.
Yeah. And as a side note, CI/CD pipelines are going to always request credentials just in time, right?
Yes.
So when you tune the life cycle or the lease lifetime of a credential that goes into a CI/CD pipeline, you want to tune it to the lifetime of the CI/CD run, right? So how long it takes for that to run. You don't want it to expire before it finishes, before that pipeline finishes, right? So those are kind of mixed. It's kind of funny. Like you can consider them dynamic credentials, but they're more just in time, just from the behavior of how a CI framework requests them.
Right. Yeah. And you don't want to be too short. If your pipeline lasts, an hour, you don't want to have your credential run out after 15 minutes. But also the other way around, you don't want your credential, your AWS credential or cloud credential to last for a year or 90 days when your pipeline only needs it for an hour, because after that, the pipeline disappears. So you kind of have to look at your workloads and figure out, what is my time frame here, and then adjust your Vault and request secrets accordingly.
And the pipeline's going to just request a new set of credentials. It's not going to go renew or use the old set of credentials, probably. It's going to request a new set of credentials from Vault if you're using a dynamic secrets engine. So it's you're just going to have hundreds, if not thousands, of leases hanging out there of AWS credentials that are just hanging out for a year. So yeah.
Yeah, you definitely want to tune them and scope them accordingly. That way each pipeline gets its own.
Nice. Okay, so let's dive into some code. You're showing Python today because we're going to go through 3 different secrets engines that are considered dynamic. We can go through the list. We should probably go through it slowly. We probably don't want to go through them all at once. Right. But we're going to start with probably the more common example that we hear about for development teams, which is the database secrets engine.
Yes, and we're going to do some hands-on first. So I'll be showing my terminal here and doing some Vault CLI commands. And then at the end, I can jump over to the Python code and kind of show you how everything works when we're talking about in an application itself.
Nice. Okay. All right. So let's get started.
All right.
Have to configure the database secrets engine, I'm guessing.
Yes. Yeah. So let's first go back and do a Vault secrets list here. So this will list all of our secrets engines that we currently have available. And if you remember from our other streams there, that is our KV engine that we were using in the past, which is the key value or kind of static secrets there. And I can even pull that if I remember what I think it was KV payments dev. And so here we have a username and password. This is something I think that we set in one of our previous streams here. So we just have Rosemary and a sample password of hello world 123. Hopefully that's not your password. So that is the static secrets engine. So now let's talk about the database secrets engine. So we can enable that Vault secrets enable. I'm going to put this on a specific path, just called Postgres, because we're going to be dealing with Postgres database engine. So the database engine supports a number of different types of databases. So I'm going to, for this demo here, just doing Postgres, but MongoDB, I think there's some Oracle, Snowflake, et cetera. There's a lot of different plugins, which we'll see here in a minute. But so I'm just going to enable this secrets engine on the Postgres path. So now if I do a Vault secrets list, we can see that we have our Postgres path, which is a type of the database secrets engine. Now from here, we kind of configure our engine. So I'm going to copy paste this big command because it's a lot to type out, but before I hit enter, we can go through it here. So I'm going to do a vault write and on the Postgres path, which is what we just created, and config, and then I'm going to configure a specific development kind of database connection. So I have a database currently running. We're going to call it just development for Vault. And then this is that plugin name that we give it. So in this case, we are doing the Postgres database plugin. Again, if you're on MongoDB or MySQL or MariaDB, Oracle, Snowflake, anything like that, there's a lot of different database plugins that you can use. So this is not exclusive to Postgres. Some of these parameters will change depending on what database plugin you're actually using. And again, for our case, we're doing Postgres. The next thing we need to do is pass in a connection string. So this is, how does Vault talk to our database that lives out there? Again, Vault is going to reach out to the database and generate new credentials for us. So Vault has to be able to connect to it. And so here I'm just giving a Postgres string. I'm using these kind of template names here of username and password. And then I have an environment variable set right now that is our host, and then the database that we're going to connect to within our database. And then because I use these templated parameters here, I'm going to also say username and password. Again, I have these set as environment variables, just not to show them on the stream here. And then the other thing that we can do is specify which roles in Vault are able to use this database configuration. And so the ones that we're going to kind of show you here today, we're going to do an admin role and then a read-only role. And so when I do that, we can now see that it was successful. We have now configured Vault to be able to talk to our Postgres database.
It is worth pointing out, though, if you're a developer and you're tuning into this, or you're an operator wondering, like, do I want developers to set this up? You probably don't. This is something that you should be jointly organizing and templating and standardizing between your Vault team and likely your database administration team, right? You want to make sure that not everybody can just create a database secrets engine. You want to be careful about what credentials are going to be passed, as well as which tables are going to be accessed. So I highly recommend that, if you're a developer looking at this and you're like, I've never seen my operations teams or my Vault teams never told me to do this, it's probably because they are doing this for you. They've worked out a sufficient policy with the database administration team. They've worked out exactly what configuration is optimal for allowing access to your application, right? So do refer to any internal documentation you might have on this. If you're a developer who has to be doing this, because you've got access to Vault and you need to set it up yourself, this is maybe going to be useful for you. But keep in mind, if you don't have to set this up because your Vault team tells you don't have to, then this is likely something that's already going to be pre-organized, configured, and standardized by DBA teams and your Vault teams.
Yes, I think a lot of this is really good if your organization gives you access to a kind of development cluster of Vault where they kind of just go, hey, go wild, learn Vault, learn how to use it. You can spin up in this case, a development Postgres database. But Rosemary is absolutely right. In a production environment, you want to work with your organization. They probably already have some sort of process that's already doing all of this kind of for them. And in the organizations that I've seen, it's usually through some automated process. So as new databases are spun up, kind of this process might already be happening automatically through some automation. So definitely work with your organizations there. So we gave Vault our username and password for Postgres. Sorry, I'm thinking here. Then one other really cool thing that we can do is, so we gave Vault the username and password. Now I know what that password was because I set the environment variable. So something that's really cool with Vault is that we're able to tell Vault to rotate its own credential in that third-party system. So in this case, we're going to do a Vault write. This -f just means force. And then we're going to do Postgres rotate root, and then the database configuration that we just set up. So this is going to rotate that Postgres password that I just gave Vault. And now that, since this was successful, the password that I have no longer works anymore. And now Vault is the only one that knows what its password is. So I initially gave Vault a password, and now running this rotate root command, Vault rotated its own password. And again, Vault is the only one that knows it. So this is something that is super useful. And I think, Rosemary, you and I just recently talked about some new capabilities around this to kind of automate this process, every month or something. So in the past, we had to manually run this command, but now I think there's some new capabilities out there where you can actually schedule this to run every 30 days or every first of the quarter or something like that.
Nice. Yeah. It's more on that. Maybe we'll show it later. I think it might not be within the function of your development team.
Right.
And as a pause, please send your questions in. I appreciate it. I think YouTube may be dropping comments or questions. So we're going to try to answer them as they come in. So as a preface for those who are tuning in on the live stream and are asking questions, we may not be seeing them. So as a warning, we'll try to answer them if you are redirected to a different platform. Sorry to pause, Michael.
No problem. All right, so we now have configured Vault to talk to our database. We gave it specific credentials. Vault is able to talk to Postgres. Now we want to use, or we need to set up roles within Vault. And let me, my copy pasting again. Just a lot of big commands here, so I think it's just easier to copy paste than me typing these out. So this one here, we're going to create a role. So we're going to do Vault write Postgres roles, and then we're going to create an admin role to talk to our database. And so this is when we request credentials, Vault will use this. When we say, hey, give me admin credentials, Vault is going to use this role to generate that. Here we specify what database does this role apply to. So here we're kind of matching up DB name equals development, which, if you remember, that's the same name that we set up when we did the configuration. And here's where we can set some of the time to lives, or the TTLs. So we're setting 30 minutes as a default, and then a 1 hour maximum. And so that means when you request credentials, they're going to last 30 minutes. But as long as you ask Vault to renew that, you can renew up to 1 hour. And then after 1 hour, your application will then request new credentials there. And then the creation statement here. So this is a kind of SQL statement. So this is what Vault is actually going to run when you say, generate me credentials. Right. So Vault doesn't necessarily know what you want to do. So in this case, because we're doing admin, we're going to create a role. We can use these kind of cool template names here with login, password, and then this password. Vault will fill this in for you. And it's going to be valid until this expiration. Again, Vault will fill that in for you. And then because it's an admin, we're going to just give it super user. Again, if you're a developer watching this, all of these roles will likely be set up already for you.
Yeah. But the important thing to know is that these roles do have permissions and access control attached to them relative to the database. So if you are struggling to access some information because you're using credentials from this role, it could be that the creation statement here does not give you sufficient access to do something against that table or that database. So it is going to be very specific to the database itself.
Yes. So that was the admin one. We're going to create another role called read only. So this time we're going to give it a 4 hour TTL with a max of 24 hours. So as long as we renew it, every 4 hours, we can use the same set of credentials for an entire day. And as this one is read only, I added this last little statement on here. So it's not super user, but instead we're going to grant it access, grant select on users to this specific name here. Again, I'm not an SQL expert. This is just something that I threw together for this example here. So now we have our roles, and now we can actually start generating kind of credentials. So we can do a Vault read Postgres creds, and then we put our, oh, hold on. Do not update Zoom. Sorry about that. So read Postgres creds, and then our specific role. So depending on your Vault policy, right? So we can use Vault policies to define access to these specific things. So if you're, a DBA, your Vault, you log into Vault with LDAP credentials, you can map that to a specific Vault policy that grants you read access to this Postgres creds admin path. If you're not a DBA and you just need read access, you can write policies to grant deny access to this creds or admin path, but grant you access to the read-only path. But doing this, this Postgres creds admin, we can see that it generated a username and password for us. And our lease duration is 30 minutes. And then we get back a lease ID. So that lease ID is the thing that Rosemary and I were talking about at the beginning, where your application can use that lease ID to renew its credential. So in this case, our credential will last for 30 minutes. But the way that we configured it, we said that the max TTL was 1 hour. So we're able to keep renewing this token until we hit that 1 hour mark.
Yeah. So we would at least renew it once, right? Because the lease duration is 30 minutes. So you could just get away with only renewing it once. And we have a good question in the chat. Does the Vault GUI have a last use time for the secret? I see it created in last modified values. I have only quickly started up in dev mode though. It does not have the last use time for the secret. That is in audit logs, and it's not transferred into the UI or within the API itself. And so there's a couple of different reasons for why this information doesn't exist hierarchically in the API or into even the GUI. And part of it is because some of this information you might want to mask or you want to protect as to who used what credentials when. And so those get written to an audit log, which is a separate, it's a completely separate system. So it's a file, usually a file or some other stream that gets written out. And then you would have the last use time for that secret, but it's not currently in the GUI, I think.
Yeah, I think you're right. Yeah. And the audit logs there, I think when we did that getting into Vault series that was more platform team oriented. And I think we talked about audit logs there. And ideally you want to be kind of sending those out to a third party kind of centralized logging solution there. That way you can build dashboards and things like that. But yeah, audit logs will have, who did what and when. So you're able to see, Rosemary pulled this admin credential on this date at this specific time, from this specific machine using this specific auth method, right? So if Rosemary usually logs in through LDAP, but someone generated a credential through, I don't know, Kubernetes auth, maybe that sets off a red flag or something.
Right. And you can track the renewal of the lease. So if you take this lease ID here, you can track whether or not it's been renewed. You can track how, it's sort of life cycle. So you can track the information about the lease, but you won't know if someone indeed actually used this since the last time. So you wouldn't be able to tell. It just tells you that it expires at this time. It was issued at this time, and this is the last time we renewed it. Yep. All right. I think that's the questions we got for now in chat that I can see. If you folks keep sending it and it's not going through, let us know. We'll try to see if we can find them.
Yeah, we'll definitely take a look after the stream. Go look through the comments and reply to them if we can't on stream. So that was the admin credentials. I could log into Postgres and do some database commands. I don't know, Rosemary, are you interested in seeing that, or do you just want to move on and generate some read-only credentials?
Let's move on and generate some read-only credentials. I mean,
okay.
You just use these credentials to log in, and at this point, folks, you would watch us type P-SQL statements and things like that. So
yeah, and I'm not a DBA, so you definitely don't want to see me typing in those statements there. But again, I can generate a whole bunch of credentials. So if I do admin, I'll just run this command a bunch, and as you can see, each time I ran it, I actually got different admin credentials. Probably not best to run this a bunch because now we have 4 or 5 different admin credentials now floating out there in the world. But again, they do expire after 30 minutes if they are not renewed. So something really cool there. And so that was admin. I can also change this to our read-only role. So creds read-only, that's what we previously set up as well. Oh,
you have to create the users table.
I do have to. Okay.
Yeah,
Sorry.
you do have to go into admin.
All right.
So it's because Michael's grant statement is select on users in Vault, right? So the creation statement that he set up grants a select on a specific table, and the table doesn't exist. So when Vault is trying to create the user with a specific permission, it actually the database is saying, well, the table doesn't actually exist at all. Yeah, so there we go. So he's going to.
There we go. We got our users table. All right.
Yeah,
now,
so
how do I quit?
/Q.
All right. It's like I'm in Vim all over again.
You're fine. You're fine. All right. So now you should be able to get your read-only credentials because now.
There. Okay. There we go. There's our read-only credentials.
Yeah.
Yes. So that was because I was, I think Rosemary did a good job there. I was panicking, copy pasting some commands there.
Yeah, it's good. And notice the lease duration is a little longer for these read-only credentials.
Yes. Yeah. And I can pull up that same thing, Vault, lease, lookup. And we can see that, it's going to last 3 hours, 59 minutes. We can see issue time, expire time, all of that. And then also kind of a cool thing that if you look at the username, you can actually see kind of the role that was used as well as the auth method. So right now I'm logged in just through the token auth method, which you might not be using in production. You should probably be using like AWS or Kubernetes or something like that, app role. Here I'm just using token, but then we can also see what role is this mapped to in Vault. And so that all of that data is kind of in this username itself.
Yeah, you can retemplate this username. So if again, you're a developer on the stream and you're looking at this and you're like, this isn't what my username looks like whenever I use the database secrets engine internally, your DBA team or your Vault team may have retemplated this so that it's a little bit different. But this is the default template you get when you make a request for a database username or password.
All right. Okay. So that's the database secrets engine. There's other plugins. So this was using Postgres, but if you're MongoDB, Snowflake, Oracle, anything like that, you can hook these up. We do have those different plugins under this database secrets engine. And again, I'm using the Postgres path here because that's what I set up when I did the Vault secrets enable database, because database is pretty generic. So I then set it to Postgres. So that's database. I have a couple more things, Rosemary, if you want to see stuff about kind of encryption as a service. Yeah, we can talk about that.
Let's talk about it. Yeah.
All right. So again, if I do a Vault secrets list here, we can see that we have our, hold on, sorry. Hold on. There we go. All right, Vault secrets list.
Oh, wait, before we move on about the database, before we move on to transit. So yes. Database, again, database secrets engine, dynamic credentials, has a lease. If you recall, go back to episode 2. That will have the patterns that apply to how you detect a database secrets engine change, right? So that way your application tracks when it is going to expire the credentials and it will request a new set of credentials. So refer back to episode 2 for those patterns. We have them in Spring and Python. The database secrets engine on its own, you're not going to necessarily find, you're not going to find that Vault is going to tell you that there's an event that happened and database credentials have changed. Your application needs to be proactive about tracking that, whether it be internally through some kind of SDK or if you do some kind of Vault agnostic approach, which is Vault Agent and then Vault Proxy. So just reminding folks. Okay, we can talk about transit because transit works a little differently.
Yeah. So I think that's a good segue. So we're now kind of leaving, dynamic secrets engine and moving into some more of like encryption as a service with Vault. So I did a Vault secrets list here, and you can see that we have our static secrets engine, which is that KV engine, and then we have our Postgres, which is our database secrets engine. So let's go in and enable. We'll do Vault secrets enable transit. So the transit engine encrypts data for us, both at rest and in transit, which I think that's where the name comes from. So now once we enabled it, it's under this path transit. We can then kind of configure it like we did with our database secrets engine. Now there's a couple different keys that you can use. There's asymmetric keys and symmetric keys. We'll just set up Vault right. Let me copy this real quick. So here we're going to set up just a transit key. The encryption key is called users. And again, there's a lot of different types of keys. This is not something developers should be necessarily worrying about. We'll worry about the developer portion in a bit later, but usually this is going to be your security teams and your platform teams working together to figure out, what is the best encryption method for the different use cases. And then from the developer perspective, all you're doing is calling an API endpoint. You're saying, hey, Vault, encrypt my data. I don't really care. I trust my security teams. I trust my platform teams. They set up the encryption. So this is great in terms of, shifting the mental load of, how does encryption work, the different types of encryption, shifting that off of developers and putting it onto Vault, and then the teams that, set up and maintain Vault there.
Because as a developer, otherwise you would have to contact your security team and ask them for, how do I get access to the encryption key in the first place, right? Do I make an API call to it? Am I storing it in my application somewhere, which is sort of defeating the whole purpose of why we're keeping everything secure anyway with an encryption key, or why we're encrypting some payloads with it. So as a developer, you typically would have to ask these questions if you did want to encrypt a payload within your application. In this case, if you are doing encryption with Vault Transit Secrets Engine, you're not going to be storing an encryption key, right? Your identity, your application identity, has access to the encryption key, and Vault helps encrypt the payload. Vault itself does not store the payload, right? It just has the encryption key and helps you encrypt and decrypt it.
Yes. So here we're going to just use this AES 256 key. So this is a symmetric encryption. Again, there's a lot of different types. Check out the documentation on the Transit Secrets Engine. Again, work with security teams and platform teams to figure out which keys work best for your use cases. So once that's enabled now, we're actually just, ready to start encrypting data. Again, this can all be done through Vault policies. It can be restricted or granted through Vault policies. But in the case of me, I have a, admin credential here. So we're going to do a Vault Write transit encrypt users. So again, this is transit encrypt in our key there. So that's what in Vault policies, we can kind of specify or limit who has access to this encryption key. As Vault is encrypting data for us, that is our plain text. So we're going to set plain text equal to, and then Vault operates on base 64 encoded data. So that's kind of what I'm doing here. And the reason that it's base 64 encoded is that you can actually do, files. So in this case, I'm doing just a sample credit card number, but you can give Vault a whole PDF. You could give Vault an image, video. So because of that, or any binary data, Vault takes in base 64 encoded data, and then encrypts that data for you, and then returns base 64 encoded data as well. So here I'm sending in this credit card number. This is something your application might do, just 1, 2, 3, 4 as a credit card. And we can see that the ciphertext that we get back here is encrypted. And something that I want to kind of call out here, that we can see that there's kind of 3 different parts to the ciphertext. The first part tells us that, hey, the ciphertext was encrypted with Vault. So when we go to decrypt the data, we should be using Vault to decrypt it. The second part here is V1, that tells us the key version, which is also down here as well. But the V1, so we store this whole thing in our database. When we go to decrypt it, we say, hey, it was encrypted with version 1 of the key. So let's use version 1 of the key to decrypt the data. Versioning also means that we can rotate this key. So we can have Vault rotate our encryption key automatically. Again, every 90 days, 1 year, whatever your organization wants to do. Vault can automatically rotate that encryption key for you. You just have to pay attention to what version the data is encrypted with. And then the last part here, this is actually the encrypted data. So I passed in that 1, 2, 3, 4 credit card number, and then it spits out this encrypted string. So this whole thing is considered the ciphertext in this case. So this is what our application would store in a database to then decrypt later. So users kind of submit information to the application. The application sends data to Vault to get encrypted. Vault sends it back to the application, does not store it in Vault, and then the application then has to do something with it. In this case, we could store it in a database.
Yeah. Commonly asked question that we get from developers is, does this introduce some kind of performance or latency concern in my application? Because now I'm reaching out to an API, I'm making an API or a network call out to decrypt or encrypt the payload if I need to do some kind of processing on it within my application. And yes, there is. There is going to be a slight performance concern. So if you do have an application that is particularly sensitive, like this has to be done very, very rapidly, there are other ways to do this. But for the most part, if you are trying to ensure that certain PII information, some personal and identifying information is protected, you may find that you need to incur a little bit of overhead or take on a little bit of overhead to protect this information. And it has a nice side effect, or not a side effect, a nice benefit that if, let's say, you have a user under GDPR or the California, I think there's a Privacy Act or something, a privacy regulation now. If you have a user who wants to invalidate their information, they don't want you to access that anymore, you can rekey and basically invalidate the ciphertext, so someone can't recover that information, right? So there are nice benefits to doing it, but there is, again, a little bit of performance overhead that you should be aware of, as well as potentially some latency depending on your network connectivity to Vault.
Right. And I will say that the transit engine actually has some really cool capabilities. I'm kind of just showing the kind of entry level capabilities, but in those kind of performant critical use cases where you don't want to be reaching out to a third party system all the time for every encryption decryption, or if you have let's say you want to encrypt some 50 gigabyte file, you don't want to send that over the network. The transit engine actually has something called data keys. So when your application stands up, your application then reaches out to Vault one time and asks for a data key, and then it keeps that data key in memory. And then all of the encryption decryption process can happen like on the machine, no reaching out to different systems there. And then when that system shuts off, then the data key disappears. So there are some kind of other cool things that you can do with the secrets engine.
Nice.
Yeah, so that's kind of the transit engine. I guess maybe something I'm kind of keeping an eye on here. I want to make sure that we can get through everything, but something here that if I run this same command over and over again, what you'll notice, even though I'm giving it the same input, we're getting kind of different outputs here. And there is a way to fix that, and that's something through convergent encryption. So if you need to do conversion encryption and always get the same, given the same input, I need the same encrypted output, you can set that convergent encryption variable to true. And Rosemary, I think you were doing something recently with this.
Yeah.
Are there any good, why would someone want, to
if you want to do analytics on certain data, right? You want to be able to do analytics on certain PII, but you don't need access to the PII directly, right? Maybe you need to know like how many times this name has come up, right, in the database, because it's some kind of dependency of some kind, right? But you don't need to know the name itself. You just need to know that the number of occurrences. So if you're doing some analytics and reporting that requires that level of detail, but you don't actually need information to the plain text, you could use convergent encryption to ensure that every time Vault encrypts the same plain text, it comes out with the same ciphertext. So as long as the same ciphertext comes up and there's a certain number of occurrences, you can still run analytics on that data set, right? Whatever that data might be in the database. So for me, I needed to know names, first and last names, and run analysis on how often they came up. And every time, if I didn't set convergent encryption, I wouldn't, everything would come out unique and I wouldn't actually have any useful information versus because I set convergent encryption, I ensure that every plain text came out with every plain text that is the same comes out with the same ciphertext. and I can run pretty accurate analytics on the information, but I don't need access directly to the names themselves.
Yeah, awesome. Yeah, I think, as you mentioned, analytics, anytime, if you were to just do this kind of basic row-based encryption here or value-based encryption, then yeah, you do lose that analytical capability, but then you can set that convergent encryption and then gain back your analytic capability there.
Yeah, exactly.
So that is the transit secrets engine. Oh, I guess I can show, what does it look like when we decrypt it? I guess that would be helpful, wouldn't it? So we'll do vault write transit. This time we'll do decrypt and then users. And then this time we give it our ciphertext, and I will give it our entire ciphertext here. And you can see that it outputs our plain text. But again, we base 64 encode our plain text. So we need to base 64 decode this plain text here. So base 64 decode, and then we'll do that. And then we can see that we get back our initial credit card number that we put in.
Little do our developer, the developer viewers know that we are learning about basic security and encryption right now. So
yes. Yes.
We took a detour, but it's kind of important. So if you do implement this in your application, or you have a requirement to implement it, keep in mind it's important to understand some of these configurations, especially when you're communicating with your security team about what kind of encryption you need set up.
Yeah, and I think from this whole stream's all about the developer side of things, and it's kind of hard to talk about Vault purely from developers, because Vault encompasses a lot of different kind of technologies that are typically spread out among an organization. When you're talking about databases and encryption and PKI, right? Like all of that's usually spread out in cloud access. From a developer perspective, it's just one API call, right? Transit, encrypt, and then whatever role you want to do. So from a developer perspective, I don't have to worry about, am I encrypting my data in the right way? Am I decrypting it the right way? Is it actually encryption, right? Base 64 encoding is not encryption. So there's all these things as a developer that, you're kind of keeping in your head, making sure you're doing the right things. By using something like Vault to offload that, you're putting it on Vault and you're putting it on your security teams to set up Vault in a specific way. Again, from a developer perspective, it's just transit encrypt, transit decrypt. It's one API path there, or I guess two API paths, one for encrypt, one for decrypt. And then you don't really have to worry about all of the underlying mechanisms and algorithms there. So that is the transit engine. Do we have time for the transform engine, Rosemary?
Yeah, we do.
All right.
So
the transform engine is also kind of in that same, let me pull up my notes here. So the transform engine's in that same realm around kind of encryption as a service. So we can Vault secrets enable transform. And the transform engine, kind of from the name, does a lot of data transformation as well as encryption and tokenization and things like that. And I think if we can get a link to that, maybe Rosemary, you're kind of working on that. And then, so I enabled it. If we do Vault secrets, Vault secrets list, we can see we have, our Postgres, our KV, our transform, and our transit engines. So let's now configure that. Let's do our credit card. So let's talk about format preserving encryption. If I go back and run one of my encrypt commands that I did earlier, so this is using the transit engine, which we just showed. Something that you'll notice, Rosemary, this doesn't really look like a credit card, does it?
No,
right?
No. And this is a funny thing. I actually asked Michael this the other day. I was like, but why would I do it? And then his explanation, very helpful. So yeah, this doesn't look like a credit card information. And my database is coded, the schema is coded to accept a string that looks like a credit card, right? So I'm like, This is useless to me.
Yeah. So a lot of people, we have this credit card data, we have our database, it has a specific schema. And then we're like, hey, now this is our schema, and that looks nothing like a credit card. So that's where the transform engine with the format preserving encryption can kind of come in. So let's copy this, and then we can talk about it. So here we're going to do a Vault write transform transformations FPE is format preserving encryption. And then this is our kind of role here, or our transformation here. So this is CCN for, this is something that I can name it, but that is for credit card numbers. And then the template here, Vault has some built-in templates around format preserving encryption. We're going to do the credit card, but there's also one around social security numbers. We're going to set a tweak source to be internal. So Vault's going to kind of handle all of that for us. And then what allowed roles are allowed to use this transformation. We're going to say users, because then we're going to generate that role here. So that kind of sets up the format preserving encryption for credit card numbers. And if we then create our role, so we said that the allowed role was a user role or users. So we're going to vault right transform role and users. And then here we can say, what transformations is this user allowed to use? So it kind of goes like both ways here. So we're saying it's allowed to use this credit card number transformation, which is what we set up in the previous command. But then also that previous command is saying the allowed role is user. So there's kind of this two-way kind of verification to make sure that the appropriate roles are using the appropriate transformations and someone can't use it without permission. All right, so that was all successful there. And now we're able to kind of encrypt our data as well. So let me get that command. Oh, that was all of it. Let's just do one of them. So in the transit engine, it was transit encrypt, and in the transform engine, it's transform encode, and then our specific role here. And then we're passing in, hey, we want to use this transformation credit card number, which again, we just set up using that built-in template. And the value here is our credit card number. And what you see when you run this command back, we get this something that actually kind of looks like a credit card number in a way. It follows the same specific format of 4 digits, a hyphen, 4 digits, a hyphen. And so this now is technically encrypted. It's format preserved encryption. And so this is really great, Rosemary. If you want to just shove this right into your database schema, you don't have to update anything like that.
Yeah. And basically, it's not the real credit card, right? It's just some encoded value now. I can always decode it if I want to. And it is worth pointing out that these are the built-in transformations, but there are transformations you can write yourself using regular expressions. So if you know like certain combinations or permutations of addresses, certain string values, emails, things like that, you can write regular expressions to transform some of these values and encode them within using Vault. But you do have to create some of them yourself. But we are currently showing the out-of-the-box ones, which are the credit card numbers and the social security numbers.
Yes. And then if you were going to store this, maybe you would want to add another kind of column in your database around, is it Vault encrypted or Vault transformed? Because if you were to just look at your database, that might look like a credit card number, or same thing with the social security number there. It follows the same format, so maybe adding a separate or adding a new column to your database could be helpful to help you, tell either you or your application that this is not actually the real credit card number. This is a encoded or encrypted version that just happens to be in the same format. So this is pretty cool. And if we actually run this again, we get the same output. So by default, it does this convergent encryption for us, which is neat.
Nice. Yeah. I will say when I was doing this with analysis, like it was probably okay, but I don't want to return it in like an application to think this is actually the real value. So if an application returns this being like, this is the actual credit card, it's not the real credit card. So I don't want to make that mistake. So you may want to actually tell your application this is an encoded value, right? It's not by any means a real credit card. Yeah.
Right. And I think it's really good in working with legacy systems. Let's say you have a really, really old, legacy system that takes in specific data. It expects a credit card format, but it's not necessarily acting on the credit card itself, right? It might be acting on some of the other user data, doing analytics, doing some type of transformation there, but it's not doing anything on the credit card data itself. And you don't want to touch that legacy system. it's running, it's working, we don't want to touch it. We can actually use the format preserving encryption to, preserve the format, give it to our legacy system that is expecting that specific format, but then is not necessarily acting on the data. So that, and I, just like we vault rate transform. So it was encode. The reverse of that would be decode users. I believe we still give it our transformation and a value. So if I do this, I don't have notes for this. I'm doing this on the fly. So let's see if it works. Hey, look at that. We get back our decoded value. So from a developer perspective, again, all your application or all you really need to know is transform encode my role, transform decode my role. You don't really have to really understand the underlyings around how does format preserving encryption work? Am I doing it the right way? Am I writing my own algorithm for encryption? Using something like Vault to do and offload that encryption really helps with developer workflows.
Yeah, nice. We do have a question in chat. Besides a fantastic question about just operating Vault, and we will get to that async. But there is someone who is asking about explaining differences between transit and transform engine again. And just to be very clear, transit is really useful if you're encrypting literally in transit, and you don't care about necessarily the format that is being output, right? You're okay with the ciphertext coming out to be the Vault ciphertext. Your database is, maybe it's useful for a greenfield application or a greenfield database table where no data has been added to it yet, and you are now just going to encrypt this payload. It's, you've already got the schema designed to account for a ciphertext that's not of a certain template or a certain structure. Versus if, let's say, with Transform is available on HCP Vault or Vault Enterprise. Transform, it allows format preserving encryption, tokenization, and some other advanced data protection techniques besides format preserving encryption, but where we're showing is format preserving FP. But it's important to know that if you have a database schema that is coded a certain way, it's expecting certain values, or you've got applications that are processing credit cards, but you don't want to break these contracts that you have with your application, then you may decide to use Transform Secrets Engine to still encrypt everything, but keep and preserve the format that your database and your application expects. It's just not using the proper data or the decrypted data, right? There are many other things. I think you have tokenization, or did you have tokenization?
I do have token. If you want to see tokenization, we can go through that.
We'll go through a couple. Yeah, we have a couple more minutes, so we could do that quickly. Transform. While Michael sets that up, Transform also includes masking as well. So if, let's say, you have an application that is, is a front end application, and it's only really going to show the last 4 digits of the credit card just to, verify that this transaction, or it's like generating a receipt, and it's only going to give like the last 4 digits of a credit card. You can opt to also use Transform Secrets Engine to mask the data before it goes into the database, and therefore when it comes out of the database, it shows everything only the last 4 digits and not anything else, right? So that's the main difference between transit and transform. Okay. All right.
Awesome. Thank you, Rosemary.
Tokenization.
Yes, tokenization. So again, this is still in the Transform Secrets Engine, as Rosemary said. It can do format preserving encryption, tokenization, masking, maybe a couple others. Those, at least I know those are the 3 big ones. So let's talk about tokenization. So this is actually not necessarily encryption. It's tokenization. So it's something entirely different. But it's I see this a lot when people work with PII or kind of really sensitive data. So technically, mathematically, encryption can be reversed. Like, I encrypt data, then I can decrypt data, right? So there exists a mathematical formula for decrypting the data, which could potentially serve some vulnerabilities there. You might not like that, especially when you're working with extremely sensitive data. So something like tokenization, we see a lot in the PII space, because there is no mathematical relation between what we input and the output that we get back, the tokenized value. They're in no way related, so there is no way to mathematically kind of reverse the process there. It is just like a mapping between this key and this value, essentially. So here I'm going to create another transformation, this time tokenization instead of FPE. And then this time I'm going to give it a social security number, or SSN, as our role name or token transformation name. Allowed roles is users, which we already created that users role. Here we can also set convergent equals to true. This is something that we talked about. This will allow us to get the same output over and over again, given the same input. Again, work with your security teams to see sometimes this is bad and sometimes this is good. So it definitely depends on your use case. And then the tokenization, we can also do different storage methods. So as tokenization is just a mapping between input value, output value, that has to be stored somewhere. And so we can actually store that in Vault itself, doing this built-in internal store. Or if you're running your separate, Postgres database or something like that, you can hook that up to Vault. So then all of the mapping process is now stored outside of Vault. So again, just kind of depends on your needs and needs of the organization. So we're able to set that up, and then now we're able to do our encoding. So let me copy this here. So Vault, write, transform, encode users. So that's essentially the same command that we did with format preserving encryption. But this time we're setting the transformation. So instead of doing credit card number, which we set up as a FPE or format preserving encryption, we're doing SSN, which is our tokenization transformation. And this time we're going to give it just a fake social security number here. And we can see that the value that we get back, this encoded token, so this is our token from the tokenization process. There is no mathematical way to kind of reverse engineer this token back into our original value. These are two completely separate values that they're not related to each other in any way other than being kind of mapped together in our database. So this is now something, this is not considered sensitive. So now we're able to send it back and forth. We can store it in our database. And then anytime we need to kind of decode this data, we can call that Vault transform decode, which if I do this, I'm going to try to save myself so I don't have to type this big command over again. Let's see, encoded. That's our value. And then let's change this from encode to decode. And there you can see that we get our decoded value back out when we do that decode command. So again, the tokenization part here is storing this mapping in Vault because we did that built-in internal store. But we could store this mapping outside of Vault in something like Postgres, for example.
Nice. All right.
Yeah.
So this is for those who are sort of like, when do I use this? When do I not use this? This is, again, something you may need to talk to your security team about if you're a developer, right? Like you may or may not do tokenization. You may find that they're going to tell you use Transit Secrets Engine because your use case is completely net new. You may not need format preserving encoding. Encoding, encryption. I'll remember eventually. I think it's encryption. Yeah. You may not need it, and in that case, right, that's a whole other question, right? So these are going to be dependent on your use case, the data that you're working with, the information that you're using. But either way, just know that you will have to make calls to Vault endpoints in order to encrypt this information and decrypt the payloads. But you can control any applications that only encrypt versus applications that decrypt this and have access to the plain text. All right. So I think we're a little over time, but we should just wrap up.
Yes.
Summary. Michael, you want to do the summary?
Yeah. I've been talking this whole time, so this is great.
You've been talking this whole time. time.
Awesome. So yeah, hopefully you've been enjoying. So at the start of the stream, we kind of went back and discussed what we've been doing, on our weekly Monday streams. Today's stream was all about kind of rotating secrets, dynamic secrets, and then encryption as a service. So we talked about kind of the differences between rotating, dynamic, just-in-time credentials there. We did a hands-on demo with the Postgres dynamic secrets engine. So we were able to dynamically generate kind of short-lived Postgres credentials, both for admins and a kind of read-only user as well. And we saw how flexible it was to kind of change the various parameters like TTL or specific creation statements or anything like that. Then we kind of went into encryption as a service with the transit secrets engine, talking about encrypting data at rest and in transit. Again, when you do that, you get a big long ciphertext, which then you kind of have to store in your database. Vault doesn't store that for you. And then we moved on to the transform secrets engine, which is kind of like an elevated, kind of more business kind of need engine there. So if you're in a large organization working with PII, the transform secrets engine is something that I would highly recommend you looking into, because that grants you access to format preserving encryption, tokenization, and masking. So some of those are encryption, some of those are kind of tokenization, which is a little bit different than encryption. But yeah, and again, we also talked about leases in Vault. So when you're doing dynamic secrets, things don't necessarily last forever. You asked Vault for an AWS credential, Azure credential, or database credential. That credential will eventually expire. So then your applications need to be able to handle that. And I think on our second stream, we talked about native integrations and how Java Spring Boot has a really good framework for kind of handling that for you. So you don't, as a developer, have to think about that. And then if you're not on Java Spring Boot, we talked about Vault Agent and Vault Proxy, which then can help with that lifecycle process there for you. So a lot of great content in these streams.
Yeah. And then the next week is going to be our last one. So last episode for this series. There are plenty of series running around, but you're only going to have the next series, the next episode in this part of the series. And we're going to talk all about Kubernetes. I know we've got Nomad folks in here. I know my heart goes to the Nomad folks. We're supposed to boot up a Getting into Nomad series at some point. But it is because KubeCon is happening next week or the week after. And by request, we were asked by folks to do a Kubernetes developer related Vault stream. So
yeah, and so that's right before KubeCon. Is that what you just?
Yeah.
Is that
KubeCon EU? Yeah.
Awesome. Yeah. So we'll do a stream on Kubernetes, and then some of our team will actually be at KubeCon EU. So then you can go ask us questions in person.
Yep. Sounds good. Okay, everyone, thanks for joining in. We appreciate you tuning in for all of the ways in which you can possibly use Vault for your development, for protecting your application secrets and other payloads. Yeah, exactly. Thanks for participating in the chat. We'll be answering some questions that are coming in async, so stay tuned for replies since we didn't get to them live. With that, thanks everybody, and we hope to see you on the next episode.